So what you guys just argue all the time, pretty much. So where should we go for dinner tonight? Italian or regular? 3 hours later, they're still arguing about whether to go out for. What's that? All right. So yesterday when we were doing the areas, right? We figured out that if I did the integral from -3 to 3, it doesn't give me the total area because I have a region that's underneath the x-axis, right? Now, right. All right, now, if another way that I could have done that, right, is if I took that area there and I put it above the x-axis, right? So it's almost like I took the absolute value of that region. If I did that, right, this would be above, this would be above, and then also this part would also be above if you're taking the absolute value of it, because it's going to make it positive, right? And that would give us the answer as well. So, if you guys are allowed to have a calculator with you, and they're asking for the area, all right, what we can do is if we can put the function that we're talking about in absolute value signs, and then find the definite integral, all right? It would not be the same number. So, like, if you right. Flip and add the negative? Yeah. All right, so it says use your calculator to find the area of the region bounded by e of x minus 3, the x-axis, and the vertical lines 0 and 3. Okay, so I have e to the x, right? And then it says minus 3, so that is a what? Transformation. Down 3, right? So if this point here, which is what? 0, 1, right? If I move that down 3, right, now I have that point at 0, negative 2, right? Okay, so the red line would be e to the x minus 3. Nope. Minus 3. Right? So we're looking at it from 0 to 3. So if I have, say, one, 2, 3. So I'm looking at it from 0 to 3, right? So I have some of the region is above the x-axis, right? And some of the region is below the x-axis, right? Yeah. 1, 2, 3. So we're trying to now figure out the area from here to here. So I have to include this piece here and then this piece there, right? So we could figure out what that point is, right? How would we do that? What's the y value right there? 0, right? So if you set it equal to 0, you got e to the x equals 3. So then x would be the ln of 3. All right? So that point right there is ln of 3 and 0. Whatever that would be, right? So we are figuring out the region there and there. Right? Now, if I just do the integral from 0 to 3 of that function, it's not going to give me the total area because of this piece right here, correct? So how I can do it is I can break it up if I want. So I have 0 to 3 of e to the x minus 3. Now, if I want to break that up into two separate integrals, right? So two separate areas, what would my first region be? 0 to ln of 3, right? Okay. So this would be 0 to ln of 3 of e to the x minus 3. And I'm going to add with that what? Ln of 3 to 3. Good. All right, so what you guys did, you just split up that total region. You split it up into two separate parts based off where the integral is. Right? Now, if I integrate from 0 to ln of 3 of this, my answer is going to be what? Positive or negative? Where is it? Where is this region in relationship to the x-axis? Below, right? So if I integrate this, it's going to give me a negative answer. So if I want to make it positive, what do I need to do here? Stick on a negative and flip it, right? That's if you're condensing down. We're trying to expand. Right. You flip the upper and the lower bound, right? No, I don't think so. Mm-hmm. Say again. Yeah, like when you work backwards with the negative on the outside, now this will become positive. Right? So another way that we could do this, even easier if we have a calculator, is we can slap on a absolute value sign, and that will help us figure out the region. Right? So well, they're all kind of like equal to each other. Like you're all kind of splitting up. So like this here should give me the same answer that I get here. Right. All right, so you guys hit Math 9. Now you need to type in absolute value. So hit the Math button again, and then scroll over once for number. The first one up there is absolute value. Yep, and you hit enter. Oh, okay. So, you want to put that part in absolute value sign. All right, so if you guys have the older ones, again, you want to make sure you hit math 9, and then hit math again, scroll over once for number, and then you want to enter for absolute value, and then type in e to the x minus 3. Second, ln. Close parentheses, close parentheses. Yeah. Remember, it's always your function, comma, x, comma, lower bound, comma, upper bound. I forgot the minus 3. Oh, yeah. All right, so second, third, minus, ah, you're right. All right, so again, I'm taking the absolute value of e to the x minus 3, right? Make sure that's in parentheses, and then make sure you're going from 0 to 3. Is it typed in like that? All right, so our answer would be yeah. All right, so see if you guys can do this one and see if you get the same answer. Not absolute, no absolute value. So try and do the last line and see if you get the same answer. All right, so I got negative math 9. Did anybody get an answer? Yeah, type it in like that. Yeah, type it in like that. So, D, I think you're right. Like, we don't want to put the negative there, because I didn't get the same answer. If you put the negative out front, and then you type it in like the rest of that, you don't get the same answer. I got 10.0855. If you put the negative out front, you won't get the same answer. So I think we did something wrong. If you do not have the negative, you will get that number. You do not want the negative. So you were right, Dave. Right? This region here, as I go from 0 to ln of 3, is underneath the x-axis, right? So if I flip them, now I'm integrating instead of left to right, now I'm going from right to left, which will then make this region positive. So I do not need to include the minus sign. No. No, you can leave it like... I don't think so. So, Preach, you're saying like type it in like that? Like the second line? Yeah, so if you do it from, if you do this, you get 10.0855, right? Which is not the same thing as this. So we figured out that this was the region that was negative. So if we flip it, it now makes this positive. No, the last one. Let's see. Yes. Yes, you're right. Right. So, all right. So we know that this region, right, is going to give me a negative answer. So if I put a negative out front, it is the same thing as flipping the upper and the lower limits. So if you typed this in, or this, you should all get 12.677. Yes. Did you remember to put the absolute value in? So if you're doing instead of having to break all these things up, we can go right to that. You did get that. Mhm. Oh, I think you switched this one. So you're going from 3 to ln of 3. It needs to go from ln of 3 to 3. Yeah. All right, so again, you can use the calculator to have like way too many integrals. You have like, or this is why I don't like the old ones. They're so hard to. ln of 3 to 3 plus. Yeah, I think you're messing up with your bounds. I think that's why you're not getting the right answer. All right, so what you guys ready? All right, so what we just did there, right? If you have a calculator, you don't really need to do all this extra math, right? You can jump right into that and you get the answer, right? We're not always going to have a calculator to come up with that, so that's why it's good to, come up with these, because you will be asked to kind of do stuff like that with functions that are a little bit easier to integrate, but you kind of need to pay attention to, all right, what region is underneath the x-axis, one region is above it, right? And that'll help you write your integral expression. So when using area to find definite integrals, we are responsible for assigning the regions the correct sign, positive or negative. So you can use area to find definite integrals, and you can use definite integrals to find areas. All right, so you have y equals f of x, a1 and a2 are positive numbers that represent the areas of the shaded regions. Find the following in terms of a1 and a2. All right, so they are saying that the area from -4 to -1, right, the area of that is a1. And then going from -1 to 4, the area of that is a2, right? So if I take the integral, though, from -1 to 4, what would my answer be? Negative a2, right, because it's below the x-axis. So you just have to pay attention if they're asking for area or are they asking for an integral. So what is the first one? The first one is from -4 to -1. And that would be what? A1, right? Right, we want all of our answers to be in terms of A1 and A2. Right, so that would be A1. All right, what did we say -1 to 4 was? Right, that region is below your x-axis. So it's got to be negative. Right, now if I'm going from right to left, if I'm going from 4 to -1, what do you get? Positive a2. Right, good. Now the whole thing, -4 to 4. Good. A1 minus A2. All right, what if we did, say, integral from -4 to 4 of the absolute value of x dx? What would that be? Good. Right, this region here, since it's below the x-axis, right, is going to be negative. That's what we got from the first one. But now if I attach on those absolute value signs, it's now going to be positive. And the last one, we said from -4 to 4, it was what? A1 minus A2 minus 2. Now, what is it from -1 to 4? Negative A2. Right, now you just have to simplify. So you have A1 minus A2 plus 2A2. Or is it plus? It's plus 18, right? Sorry. All right. Okay, so does that make sense for everybody? How that works? If they're asking for, you know, the area, again, it's going to be a little bit different, right? This integral here from -4 to 4 of the absolute value would give you the total area of that, right? But because I have part of it is underneath, it's no longer the area. All right, number 8 says sketch the region, then evaluate each integral using a geometric formula. Decide if the integral represents the area of the region. All right. So I have 4 dx from 1 to 3. So what type of line is that? Not a vertical. Horizontal. All right, so if we're looking at it from 1 to 3, what are we figuring out the area of, or the integral of? That is a what? Rectangle, right? So what would my answer be? 8, good, right? So this is 2, right? And then 4. So 2 times 4 would give me 8. So take the what? What are you asking? No, don't do that. All we're doing is we're taking the function that they give us. We're going to try and sketch it and figure out an area formula to figure out the integral. All right, you got x minus 2 going from 0 to 3. So if you plug in 0, right, you get -2. And then if you plug in 3, you get 1, right? And then what is my x-intercept? 2, right? X minus 2 equals 0. All right, so we're trying to figure out this part here and then this part here. So we have 2 triangles, right? Now, is this going to represent the area from 0 to 3? No, right? Because we got this chunk here that is underneath the x-axis. So you have 1/2 of the base, which is 2, so that's 1, times the height, which is, so that piece right there is 2, and then the last piece right there would be what? Oh, you're right, 1/2. Right, half of your base is 1, half of that is 1/2 times the height, which is 1, so that's 1/2. So if I now take the integral from 0 to 3, what is it going to be? Say again? Good. So the integral going from 0 to 3 of x minus 2 dx would be -2 plus 1/2, which is -3/2. They'll tell you. Like they'll say area or, if not. No, we're just finding the integral. Right. So this would not be the area going from 0 to 3 because of this piece here. If I were to ask you what would the area be, what would the area be? 2.5. Right. Right. Okay. Square root of 36 minus x squared is a what? What type of equation is that? Yeah, I know that, but what else? It's a semicircle, right? R squared minus x squared. What is this number here? 6, right? So we are figuring out that area, right? And that is a semicircle, right? Pi r squared is a circle, so, right. Right, and my radius is what? 6, right? So you have 1/2 pi times 6 squared. So your answer would be what? Right. Yeah, it's all above the x-axis, so yeah. Correct. Then would it be the area? So then, like, say that, like, this piece here was below, we would have to figure out what's the area of that piece, figure out the area of that piece, and it would be this piece minus that piece, because this piece would be negative. Yeah. All right, last one. Square root of x, not square root of x, absolute value of x over x. What function is that? So if you plug in like 5, what do you get? If you plug in -5, what do you get? All right, so we're going from -1 to 4, right? So this piece right here would be what? 1. And then this piece here would be what? 4, right? So if I do the integral, what would it be? 3, nice. Right? This is below, so it's going to take away what I've accumulated on top. So it would be 3. It's kind of what summer was for. Sorry? Be 5. Yeah.